Okay, good day. So our topic for today is arithmetic progression. So how do we distinguish a progression? Or how do we distinguish the progression? So since we have three popular types of progression, we have the first arithmetic progression, geometric progression, and the harmonic progression. So for arithmetic progression, for example, we have the terms a sub 1, a sub 2, a sub 3 up to let's say a sub n. So for a progression to be distinguished as an arithmetic progression, we should have a common difference. So let's say we have this is the common difference. That is, we have a sub 2. Our common difference should be equal to second term minus the first term. Common difference is also equal to the third term minus the second term, fourth term minus the third term, and so on. So for example, how do we compute for the second term? Our second term, a sub 2, transpose, that is the same as the first term plus the common difference. How do we compute for the third term? Third term is equal to, transpose the second term, a sub 2 plus the common difference. So, what is the equivalent of the second term? So, you have the equivalent of the third term, that is second term. What is the equivalent of the second term? That is a sub 1 plus the common difference. Plus the common difference. So, you have the equivalent of the third term to be the first term plus twice the common difference. Okay, from this idea, we have a sub 3 is equal to the first term plus twice the common difference. How do we compute for the nth term for our general formula? Let's say we have, this is a sub n. We need the first term, that is a sub 1, plus, can you observe? We have a subscript of 3, and what is our multiplier for the common difference? That is 2. So if this is n, what would be the multiplier of the common difference? If this is 3 for n, the multiplier of the common difference should be n minus 1. So this is our formula for the nth term of arithmetic progression. So this is equal to a sub n is equal to a sub 1 plus the number of terms minus 1, that quantity multiplied by the common difference. Then, for arithmetic progression, we have arithmetic mean. So basically, if we say arithmetic mean, that is just averaging, the averaging of the terms, or the average of the terms. So you have, let's say, the arithmetic mean of n terms, that is the same, let's say, a1 plus a2 plus a sub 3 up to plus a sub n, averaging divided by the number of terms. So this is our arithmetic mean. So let's have a simple example. Okay, so for example, we have the series 2, 5, 8. So we are required to determine the 20th term and the arithmetic mean of the first 5 terms. So first, let us determine if this is really an arithmetic progression. So we have the common difference. We have 5 minus 2 is equal to 3. Common difference, that is 8 minus 5 is also equal to 3. This means, we have an arithmetic progression. So how do we compute for, we have letter A, we are looking for the 20th term. That is at n is equal to 20. So our first term is equal to, we have 2. So we have a sub n is equal to a sub 1 plus the n minus 1 times the common difference. We have a sub n, or this is And we say now we have a sub 20. What is our first term? This is 2 plus. Okay, for the 20th term, we have 20 terms. That is 20 minus 1 times our common difference. We have, this is 3. So that is our 20th term equal to. Okay, so we have that is 19 times 3. Okay, plus 2. So our 20th term is equal to, we have 59. So that's our solution for our first required. And the second requirement, we have letter B. So we are looking for the arithmetic mean of the first 5 terms. So what okay, for letter B, what are the terms? We have 2, 5, 8. As you can see, our common difference is 3. So this is 11. Okay, that is 3 plus 8. 11 plus 3 is 14. We have now 5 terms. So for the arithmetic mean, all we have to do is average our terms. That is 2 plus 5 plus 8 plus 11 plus 14. This is divided by how many terms? Okay, we have 5 terms. So this is divided by 5. So that's determine our arithmetic mean. We have 2 plus 5 plus 8 plus 11 plus 14. This is divided by 5. So our arithmetic mean of these 5 terms is 8. Okay, that is for the arithmetic mean. Okay, so we proceed to the summation or sum of the n terms of an arithmetic progression. How do we compute for the sum of the terms? So basically, we have the sum is, for example, first term plus the second term plus the third term up to the nth term. Or if we are to expand this one, the summation is first term plus what is the equivalent of the second term? That is the first term plus the common difference plus the third term, that is the first term plus twice the common difference, and so on. So this is by adding the common difference, and we are starting on the first term. How about if we are to do it in a way that it is decreasing? The sum is, what if we start on a sub n? So we have a sub n in a decreasing manner. What is the term before a sub n? That is the same as a sub n minus the common difference. Okay, plus the term before the term before a sub n minus d is the last term minus twice the common difference, and so on. So from these two equations, okay, we are to determine the sum. Equation 1 plus equation 2. So this will be twice the summation. So if we are to observe, we are to eliminate the common difference. So what are the remaining terms? The remaining term on the first equation will be the first term, that is a sub 1. And the remaining terms on the second equation, we have a sub n, that is the nth term or last term, a sub n. The question is, how many a sub 1? How many a sub 1? So take note, we are dealing with the n terms of an arithmetic progression. So the number of remaining a sub 1 and remaining a sub n is n terms. So if we are to divide both sides of the equation by 2, we have now the summation as the number of terms divided by 2 multiplied by the first term plus the last term. So this is one equation or one formula for the sum of the terms of an arithmetic progression. But if we are to recall, what is the equivalent of a sub n? That is the same as a sub 1 plus n minus 1 multiplied by the common difference. We substitute a sub n in this equation. So we have the summation is equal to number of terms over 2 multiplied by the first term. This is first term. Plus, what's the equivalent of a sub n? We have, that is the same as a sub 1 plus the n minus 1 multiplied by the common difference. So we further simplify the sum of the terms of an arithmetic progression. We have the number of terms divided by 2 This is multiplied by, okay, we have a1, this is twice the first term, okay, plus we have n minus 1 times the common difference. So another form of the formula for the sum of the terms of an arithmetic progression. So let's have an example. Okay, so let's have an example for the sum of the terms of an arithmetic progression. So example, we are required to determine the sum of all numbers from 5 to 250 that are divisible by 4. So since our lower limit is 5, obviously, what will be our first term? That will be the first number which is divisible by 4. After 5, that is, obviously, we have 8. So what is our last term? A sub n. Is it 250? So let us first determine if 250 is divisible by 4. 250 over 4 is equal to... So I think this is not divisible by 4. It is 62.5. So if we say divisible, our quotient should be a whole number. So it means 250 is not our last term. So let us consider maybe our last term a sub n. I think to be divisible by 4, we can have 248. Why is it that 248 can be the last term? 8 is divisible by 4. Our last number is divisible by, our last digit is divisible by 4. So it's just, we don't know how many terms from 8 to 248. So we are to determine how many terms. That is, we are using a sub n, so do a sub 1 plus the number of terms minus 1 multiplied by the common difference. To be divisible by 4, obviously, what is our common difference? So if we are to start with 8, what is the next one? Divisible by 4, 12, 16, up to 248. So obviously, 248 is divisible by 4. So how many terms from 8 to 248? Obviously, our common difference is 12 minus 8, 16 minus 12. It's equal to, our common difference is 4. So what is our n term? We have 248. What is our first term? That is 8. Plus the number of terms minus 1, our common difference is 4. So we have how many terms? So we have 248 minus 8, that is divided by 4, plus 1. So we will be having 61 terms. Okay, 61 terms. How do we compute for the summation? The summation of the terms is the number of terms over 2 divided by the quantity first term plus the last term. So we'll be having a summation of, we have how many terms? This is 61 divided by 2. Our first term is 8, our last term is 248. So the sum of the terms, I will be having 7,808. So this will be our answer for the sum of all numbers from 5 to 250 that are divisible by 4. So let's have more example for arithmetic progression. So let's have this more example for arithmetic progression. So the third and eighth term of an arithmetic progression are 9 and 24 respectively. Find the 20th term. So we have first problem. Our third term is equal to 9. Our 8th term is equal to 24. So from the equation, a sub n is equal to a sub 1 plus n minus 1 multiplied by d. For the third term, this is 9. We don't have the first term, a sub 1 plus this is 3 minus 1 times the common difference. So we have this is 9 equal to the first term plus twice the common difference. Okay, this is for third term. How about for the eighth term. So take note that we have n is equal to 3 for the third term, n is equal to 8 for the 8th term. So this is, we have 24 equal to the first term plus, on the 8th term, we have 8 minus 1 times the common difference. So we have, this is now 24 equal to the first term plus 7 times the common difference. So take equations to unknowns. So this is 9 equal to a1 plus 2d. This is 24 equal to a sub 1 plus 7 of d. Okay, we may do elimination. So this is 9 minus 24, that is equal to negative. This is negative 15. So a1 minus a1 is 0. 2 minus 7 is negative 5 times the common difference. So our common difference is negative 15 divided by negative 5 is 3. So we are now looking for the 20th term. That is at n is equal to 20. Or before that, we need to determine the first term. So we have, that is, for example, I'll be using the first equation. 9 is equal to a1 plus twice the common difference. This is 3. So our first term is obviously 9 minus 6. We have 3. That's our first term. So common difference and the first term. So we have n is equal to 20. Our 20th term is now equal to 3. First term times 20 minus 1 times the common difference, which is 3. So you have the 20th terms now equal to 3 times 19 is 57 plus 3. We have, obviously, I think this is 60. This is an easy problem, supposedly. I think it's obvious since 9 is the third term. So I think it is obvious that our common difference is 3 and our first term is. So let's have the second problem. So our answer is 60 for the 20th term. Problem number 2. So for problem number 2, find the sum of the first 11 terms of the arithmetic progression, negative 22, negative 14, negative 16. So our first term is equal to negative 22. What is our common difference? That is a sub 2 minus a sub 1. Common difference equal to our second term there. We have a sub 2 is equal to negative 14. So this is, second term is negative 14 minus, we have negative 22. So obviously our common difference is positive, it should be positive 8. Okay? And the number of terms required is 11. So we can have the summation as the number of terms over 2 multiplied by twice of the first term plus n minus 1 times the common difference. So we'll be having the summation. This is how many terms? 11 over 2 is multiplied by twice. What is our first term? Negative 22. Okay, plus the number of terms, we have 11 minus 1. Our common difference is positive 8. So we'll be having the summation. Positive 198. This is one way to solve this problem. The other way is we may determine the 11th term using a sub n is equal to a sub 1 plus n minus 1 times the common difference. A sub 11, what is our first term? We have negative 22 plus 11 minus 1, a common difference of positive 8. So we have a sub 11 is equal to, that is negative 22 plus 11 minus 1, I multiplied by 8. So our 11th term is, this is positive 58. Okay, the sum is equal to n over 2 divided by a1 plus the a sub n. So summation is equal to number of terms 11 over 2 multiplied by our first term is negative 22 plus our 11th term is positive 58. So let us see if we are to arrive with the same. Okay. Should be. So we have the same answer of 198.